Hello class, this is Mr. Parsons here. I'm going to take a few minutes to talk to you about functions. And basically a function is this relationship between your input and your output. Your input, think of an ordered pair. So your input is your x values, your output is your y values. In the previous lesson we talked about relations, right? So your x value, which is your domain, which is also your independent variable, and now your input, your y value, which is your range, your dependent variable, and now your output. And so what you want to do is you want to see for every one input you have exactly one output. And there's a couple ways to look at that. When you're looking at mapping, or when you're looking at a table, or you're looking at ordered pairs, you want to make sure that your input, which is your x value, it doesn't occur more than once within your relation. If it occurs more than once, then it's not a function. But if it only occurs once within your relation, then it is a function. Graphically, what you want to do to identify if it's a function, you want to do a vertical line test. Just draw a straight line down your graph. So if it's a continuous graph that connects, if it intersects the graph only one time, then it is a function. If it intersects the graph more than one time, it is not a function. Now we have discrete graphs, which is individual points. You still do the vertical line test. It's just that if it intersects only one point, then it's a function. But if it intersects more than one point, then it's not a function. And so this is what I was talking about here with the vertical line test. So look at this graph. I'm doing a vertical line test. Notice I'm only intersecting the graph one time, no matter where I go along this graph. So that means this is a function that passes the vertical line test. If I look at this example, notice I do the vertical line test, and I'm intersecting this graph more than one time. And so because of that, it doesn't pass the vertical line test, and it's not a function. All right. Look at your mapping. So look, for every input, you got exactly one output. There's only one line coming from my domain to my range. Only one line coming from my domain to range. So this would be a function. All right. If you look at so it's a function. All right. Now if you look at part B, look at your domain, which is your x values. Notice 2 occurs more than once within your x value, within your relation. Since there's a number that occurs more than once for your x value, this is not a function. Look at my ordered pairs. You want to look at your x values. Notice that the number 4 occurs more than one time for your x value. And so because of that, this is not a function. All right, let's take a look and determine which of these is a function and which is not. All right, so let's look at our ordered pairs here. And if we look at our ordered pairs, look at our domains, which is our x values. All right, none of these numbers occurs more than once, so this would be a function. All right, let's look at our table. So look at our x value for our table. Notice we got negative 0.2 occurs more than once for our x value. And so because of that, it is not a function. Let's look at our graph here. For our graph, what you want to do is do the vertical line test. If we do the vertical line test, notice that we intersect our graph more than one time. And so because of that, it doesn't pass the vertical line test. Since it doesn't pass the vertical line test, it's not a function. All right. Look at this graph right here. We do the vertical line test. It only intersects the graph one time. It passes the vertical line test, so it is a function. All right, let's look at this table right here. We look at our x values. There's no x value that occurs more than one time. Yes, they all share the same output. That's fine, but as long as it doesn't share the same input. So this is a function. And then lastly, look at this mapping. Notice what this is telling me is 6 occurs more than one time in our ordered pair. because there's more than one arrow coming from 6. 12 occurs more than one time in our order pair because there's more than one arrow coming from 12. So this is not a function, all right, because 6 and 12 occurs more than once. All right, let's see. Which of these are functions? So just take a second to see if you can identify which one of these are functions. Pause the video and see which one of these you think is a function. Okay, let's take a look. So if we look at this right here, there's one arrow coming from each x value. So this looks like this is a function. For every one input, you have exactly one output. Let's look at our table. So if we look at our table, the number 0 occurs more than once. So this is not a function with the table. And then let's look at our order pairs. If we look at our order pairs, look, -2 occurs more than one time. So this is not a function. So the answer to this question will be A, number 1 only. Now we want to look at evaluating functions. So when you evaluate a function, you're given a function that's in function notation. All right, so instead of you saying y equals a number, you can just have f of x, g of x, whatever that function is named. And then you're going to substitute whatever number, all right, into your equation, into your function. So if I look here, this is saying f of x equals -2x plus 9. I want to find f of 4 plus 3, and I want to find f of 5 minus f of 1. Basically, let's start with this example here. What it's telling me is I need to substitute 4 into this function, and then once I solve it, then add 3. That's basically what it's saying. For this one, it's saying that I've substituted 5 into this function, and then I'm doing another function where I'm substituting 1, and then I'm subtracting it. So let's go ahead and break down these examples. So for this one, all right, substitute 4 into our function, so -2 times 4 plus 9, instead of -2x plus 9, and then we're going to add 3. So -2 times 4 is -8, -8 plus 9 is 1, and then we just do 1 plus 3, that gives you 4. So 4 will be our output here when we evaluate this function. If we look at this particular one, so notice we're using the same function, but we're doing one when we substitute 5 for x, and we're doing another one when we substitute 1 for x, and we're going to subtract them. So we're going to do -2 times 5 plus 9, and then -2 times 1 plus 9. -2 times 5 is -10, so I got -10 plus 9. -2 times 1 is -2, so -2 plus 9. And so -10 plus 9 is -1. -2 plus 9 is 7. And then if I do -1 minus 7, I get -8. All right, let's take a look at these. Let's try to see if we can apply these here. So this is our function, -3x plus 2, and we want to find the value. So for A, we're just substituting -4 into our function. So we're going to have -3 times -4 plus 2. All right, -3 times -4 is 12. 12 plus 2, that's going to give you 14. So 14 is the answer. And then for B, we're substituting 5, but then we're going to add 8 afterwards. So we're going to have -3 times 5 plus 2, which is our function, and then we're going to add 8. So -3 times 5 is -15. -15 plus 2, that's going to give you -13, and -13 plus 8 is -5. So -5 will be your answer. And then for this one, what we're doing, we're going to do -3 times 3 plus 2 minus -3 times 6 plus 2. -3 times 3, that's -9. So -9 plus 2. -3 times 6 is -18. So -18 plus 2. And then we do -9 plus 2, we get -7. -8 plus 2, that gives you -16. So we do -7 minus -16, you get 9. So 9 will be our value here. All right. And then let's take a look here when we're evaluating this right here, and we'll get into this when we get into quadratic functions. But this our polynomial, which is is our standard form for our quadratic function. But anyway, what we're doing here is we're doing the same thing, but we're doing for this particular polynomial. And so we're going to do, we're substituting 2 everywhere we see x. Here we're going to substitute 4 everywhere we see x, and 1 everywhere we see x, but then we're going to subtract. And then lastly, we're going to substitute 5 everywhere we see x, and then subtract 7. So let's start with the first one. All right, we're substituting 2 for x. So we're going to have negative 6. This is supposed to be squared to the second power. Negative 6 to the second power plus 8 times 2 plus 36. All right, 2 to the second power is 4. 4 times negative 6 is negative 24. And then 18 times 2 is 36. We do negative 24 plus 36 plus 36. That gives you 48. So 48 will be our answer. Here, what we're doing is we're substituting 4 everywhere we got x. And then we're doing another function. We substituted 1 everywhere we got x. And then we're going to simplify those two, and then we're going to subtract them. So 4 squared is 16. 16 times negative 6 is negative 96. And then 18 times 4 is 72. All right, plus 36. And then 1 squared is 1. 1 times negative 6 is negative 6. And then 18 times 1 is 18. So we're left with negative 18 plus 36. So we just go ahead and do these brackets here. Negative 96 plus 72 plus 36. That's going to give you 12. And then negative 6 plus 18 plus 36 gives you 48. And we do 12 minus 48, we get negative 36. Okay, look at this one. We're substituting 5 here, we got x. And then we're going to subtract 7 afterwards. So we got 5 squared, which is 25. 25 times negative 6 is negative 150. And then 18 times 5, that gives you 90 plus 36. And so we do negative 150 plus 90 plus 36. That gives you negative 24. And then we're going to do negative 24 minus 7. All right, which gives you negative 31. So negative 31 will be our answer here. Let's go ahead and complete these. This is our function. So we're going to substitute 4 into our function. So we're going to have 6 times 4 plus 9. 4 plus 9 is 13. 6 times 13, 78. Do the same thing for part B, but we're going to substitute x for negative 6. So we're going to do 6 times negative 6 plus 9. Negative 6 plus 9 is 3. And then 6 times 3 is 18. So 18 will be our answer. All right, let's look at number 2 here. We're substituting 1 for x. So we're going to have 1 squared minus 12. 1 squared is 1, and then 1 minus 12 is negative 11. So negative 11 will be our answer. All right, and then for part B, we're going to do negative 3 for x. So negative 3 squared minus 12. Negative 3 squared is 9. 9 minus 12 is negative 3. So negative 3 will be our answer. And then lastly, we're using this function. We're substituting negative 8 everywhere we see x. So we're going to have 8 minus negative 8 divided by negative 8. 8 minus negative 8 is 16. And so 16 divided by negative 8 is negative 2. So negative 2 will be our answer. And then lastly, we substituted for 8. So we're going to have 8 minus 8 over 8. Well, 8 minus 8 is 0. And 0 over 8 is 0. So 0 will be our answer for here. Okay, so just to recap what we looked at here is we try to identify a function. And so when we identify a function, you got to have every one input for exactly one output, meaning that within your order pairs, the x value in your order pair can't repeat more than once within that relation. If it doesn't repeat more than once, it's a function. If it does repeat more than once, it's not a function. Same thing for mapping, same thing for your table. For your graph, do the vertical line test. If it crosses your graph only one time, it's a function. If it crosses the graph more than once, then it's not a function. When it comes to evaluating your function, just take the value that's given, all right, and you substitute it for everywhere you see your variable in your function to solve to get your output. So I hope this helps with our understanding of functions.